The next trajectory we want to address is the isochoric trajectory. So isochoric, what does isochoric mean? Well, it's an unusual word. It's not typically used in conversation, but isochoric means that the volume is equal to a constant. It means that delta V then is equal to 0. This turns out in thermodynamics to be an extremely important trajectory. And so we want to look at our triad again. We want to look at what happens mechanically with the machine. We want to look at our PV coordinate system. And we want to look at the manifestation of the first law of thermodynamics that relates delta U for the system to the heat and the work. So let's take a look at this. This means that the volume is fixed. So that means on our machine, whatever we're going to do to this, we're going to have a pin that locks the position of the piston, because if the change in volume is equal to 0, that means immediately that the work done is equal to 0. So when we plot this on a PV coordinate system, for example, if we're extracting heat, the pressure is dropping, but the volume remains fixed. So that means that we've put a block of ice underneath our machine, and that means that heat is flowing from the system into the ice, extracting heat, and we know immediately that Q must be less than 0 in this case. Well, so we have Q less than 0 and work identically equal to 0. So when we look at the first law, again, we have no chemical reaction, so we don't have to worry about the chemical side of internal energy. We're starting with 1, 2, 3 units of thermal energy. The work term is 0, so it doesn't enter into our calculation. But as we extract heat, let's suppose we're taking out 2 units of heat by placing this machine on a block of ice. Heat is leaving the system, so Q must be less than 0. And so the difference between the heat extracted and the initial internal energy means we're subtracting 2 units from our original 3 units. That leaves only 1 unit of thermal energy left in the final state. But we've kept track of the initial and final internal energy and the heat and work terms.